So if I want to describe the list of values that I've got here, I've got the numbers, the whole numbers, ranging from 6 through to 11. Now that's quite a lot of words to say. Writing it as a list is annoying. So we need some new ways of describing this list, this set. So the first one is precisely that. It's called set notation. And the set is described by these curly brackets. So we'd say the set of x, where x is a number and it's an integer, such that x is anything from 11 down to 6 inclusive. Now, in reality, in the exam, all you need to write is x such that x is in between 11 and 6 and include your brackets. So you don't need to mention the integer bit. So that's one way. You can see that that's condensed that down. So sets allow us to write rules. This inequality here is a rule for what values of x I can take, and it has written my list far more succinctly than just writing it out. The other option is interval notation. So intervals talk about the kind of period of time or space or numbers that you are interested in. It's a particular, literally an interval. So I want the interval that includes 6 and runs up to 11, and I want to include both of those. So I'm going to use the square bracket notation. So square brackets include, conversely, curly brackets, that second one does not look curly, there we go, just round brackets don't include. So I could equally write this, I guess, as 5, 12, non-inclusive, because I'm actually then including 6 through to 11. So in set notation then, this this region described to the left here, this one here, would be x such that x is strictly less than minus 5. Notice the open circle here means strictly less, and I've got a set. Now on the other side, I've got x such that x is greater than or equal to 5. Notice the filled in circle here on the top of the notation. But I'm simultaneously describing these regions, aren't I? I've got a diagram with both of them on. So I want to be able to connect my two sets. And I'm going to do that using the union. So union means or, basically, in essence. It's one or the other or both. So it's the most encompassing thing that we've got, hence union. So we would connect our two sections of set notation with the union. I could write this in interval notation. So I would say that this is minus 5, not inclusive, and then onwards forever, i.e. down to minus infinity. Now, infinity is a concept. It's not a number that I can pin down, so I can't include it. I can't include a concept in a list of numbers. Likewise, on the other end, I've got 5 inclusive, so I want a square bracket here, up to positive infinity because I'm running forever, but again, not inclusive. I can't include a concept. I'm simultaneously looking at either section, so again, I want the or in there. The alternative is an and, having both simultaneously, absolutely having both of them. And that is a little, it's called a cap or an intersect. And this is kind of your and. So if you want to talk about both simultaneously, use the and. So just to quickly recap, this is a topic that will appear in lots of others. So we will see these again in quadratics. We will see this all again in probability and probably countless other places. They'll find some fun way of putting them in. So we're not going to spend too much time on this in lessons, but just to remind you, set notation has the brackets x such that and some rule that describes all of the values in your set. Interval notation just talks about the numbers that they range from, and you could have any combination of curly and square brackets, where the round brackets here represent not included and the square brackets represent included. You then have connectors. Your union or your cup is or, one or either or both, and your cap or intersect is equivalent to and, so both together simultaneously. And that's it. Hopefully you'll get lots and lots of practice in this in lessons, but this is just a little video to just give you a recap.